Welcome in refrigeration and air conditioning lecture. Today we will continue unit number 6, air distribution system. In last lecture, in air distribution system part 1, we have already studied what is duct, then different types of ducts, classification of duct, then flow through duct and pressure losses in duct. Now in this lecture we will see duct design. So in duct design, it is very important topic. When we go for the duct design, then the basic inputs required for the duct design is nothing but the required supply airflow rates to the condition space. So we must know, so if you see from load estimation and psychometric calculations, the required supply airflow rates to each condition space must be known. This is the input. The second input that we require for the duct design, that from the building layout and the location of supply fan, the length of each duct run is known. So these are the two inputs required for the duct design. So the purpose of duct design is to select suitable dimensions of duct for each run and then to select the fan, which can provide the required supply airflow rate to each condition zone. So the design of duct is nothing but to find out the diameter of duct in circular duct and find out the sizes of duct in square and rectangular ducts. So the duct run with highest pressure loss is called as index run. So if you see the terminology index run, that you can identify, that is, if you see in duct design, this is the fan, and this fan circulates the air to the condition space 1, 2, 3, 4 and 5. So in this case, these are the branches of ducts. You can see these are the number of branches of duct. Then index runs means, if you consider the fan is circulating this or distributing this air from A to H, then what happened, there will be a pressure loss from this point A to H. If it is the maximum in this duct system, then you can say it is your index run. So that is called as your index run. So here this fan distribute this air to the different branches of the duct at the location 1, 2, 3, 4 and 5. So when we go for the design of duct, then it is very important to study different methods of duct design. So there are basic 3 methods of duct design: velocity reduction method, equal friction method and static region method. So here we will see the first method of duct design, that is velocity reduction method. So in this velocity reduction method is one of the simplest way of designing the duct system for both supply and return air. So for both cases we can use this type of duct design method. However, the application of this method requires selection of suitable velocity in different duct run, which requires experience. The method is not very efficient as it requires partial closing of all the dampers except the one in the index run, so that the total pressure drop in each run will be same. So if you see in this velocity reduction method, you can see that you can select the velocity initially first for the different duct runs. So these are the different duct runs, and for these different duct runs you can select the velocity, and accordingly we can go for the design of duct, means to find out the dimensions of the ducts, that is the calculation of diameter of duct system. So next method is your equal friction method. In equal friction method, this method is, you can see this method is based on the principle that the friction rate per unit length in entire duct system would be maintained constant. Thus the size could be calculated for different discharges by keeping friction rate constant. So in last method, that is velocity reduction method, we have to decide the velocity. This parameter is important by selecting velocities for different duct lengths. We go for the design of duct, means for calculating the diameter of the duct. But here you can see that this method is based on the principle that frictional rate per unit length, that is frictional rate per unit length, remain constant throughout the duct system. So throughout the duct system, if you consider, then this friction rate per unit length remain constant, and based on this you can go for the sizing of the duct to find out the size of the duct in circular duct, square duct or rectangular duct. So this method usually yields a better design than a velocity method, as most of the available pressure drop is dissipated as friction in the duct runs rather than in the balancing damper. So this method is generally suitable when the ducts are not too long, and it can be used for both supply and return duct. However, similar to velocity method, the equal friction method also requires partial closure of damper in all but the index run, which may generate noise. So here you can see that this partial closure of damper we are used for uniform distribution of the air. If you see that in both velocity reduction method as well as in equal friction method, there is a need of this damper closing for maintaining the basic parameters to pressure drop at each section of the duct, or each, you can say, the part of the duct in velocity reduction as well as in equal friction method. So the last method of duct design, that is a static regain method. So this method ensures that at the end of each section or branch, the static pressure is same all throughout the system. While in case of, we already seen in velocity reduction method, we are considering velocity initially, and based on this velocity we find out the size of the duct, that is the diameter of the duct. Also in second method, equal friction method, we are considering the frictional loss per unit length remains same throughout the system, throughout the each section and branch of this duct, but here the static pressure is same. In static regain method, the difference is that the static pressure is same all throughout the system. The reduction in velocity at the beginning of a section is done such that the static pressure regained by reduction in velocity head is sufficient to take care of frictional pressure drops in the section. So we are initially considering some velocity, and by initial velocity there will be a continuous reduction of velocity at each section because we need to maintain the static pressure same throughout the system. That's why there will be a reduction in velocity when we go along the length from initial velocity to final velocity. So the advantage of this method, it ensures constant static pressure at each branch, takeoff and outlet, so the final balancing of the distribution is easier. So here the static regain method yields a more balanced system and does not call for unnecessary damping. So here you can see that this damping we are not required in the static regain method, while for the balancing purpose in velocity reduction method and equal friction method we require the controlling of the damper. Here, however, as velocity reduces in the direction of airflow, the duct size may increase in the airflow direction. So that is the basic drawback, that when your velocity reduces in the direction of airflow, for maintaining the static pressure remain constant, the size of duct increases in airflow direction. Also, the velocity at the exit of the longer duct runs may become too small for the proper air distribution in the conditioned space, because initially we required higher velocity, but this velocity goes on decreasing. For maintaining this constant regain, static regain that is constant we are maintaining throughout the system, and for that velocity at the exit of a longer duct goes on decreasing. So for proper distribution to the conditioned space may become too small. So here these two are the disadvantages of this static regain method. So here we studied what is duct design and the methods of different duct design. So thank you. If you have any query regarding this topic, you can mail me on vinodcs31576@gmail.com. Thank you.